Today we're going to start the first lesson in a unit called rational expressions. Now, don't want to scare you, but I'm going to tell you that I think this unit on rational expressions is the hardest unit in the whole course. So just prepare yourself. We're going to use some things from previous units, things like factoring, simplifying, determining non-permissible values, things like that. So some of what you'll see in this unit is useful from other units, but there's a lot of new stuff. Now, let's talk about rational expressions, excuse me, a little bit before we get started. Previously, in early grades, probably even back in elementary school, you looked at fractions, and a fraction is a quotient of two integers, and we call it a rational number. In this unit on rational expressions, well, basically a rational expression is the quotient of two polynomials. So it's something like x plus 7 over x plus 8. So basically a rational expression is an algebraic fraction in one variable. So that's part of what makes this unit hard, is that we're going to be dealing with fractions, which can be difficult for some people, and now we're going to add algebra into the whole idea of fractions. So in this unit, we're going to learn how to add, subtract, multiply, and divide rational expressions or algebraic fractions. But before we can learn how to add, subtract, multiply, and divide, we actually have to learn how to simplify rational expressions. So that's where we're going to head. All right, so what we're going to look at is we're going to look at two different rational expressions. We're going to look at 2x plus 2 divided by x squared plus 3x plus 2, and we're going to look at 2 divided by x plus 2. And we're going to complete this table. We're actually going to figure out values for these expressions. So basically what they've given us here is they've given us some values of x. So we're going to substitute those values of x into each of these rational expressions, and we're going to see what do we come out with as a result. So if we substitute in 0, we get 2 times 0 plus 2 over 0 squared plus 3 times 0 plus 2. Well, in this case, 2 times 0 is 0. 0 plus 2 is 2. 0 plus 0 added to 2 gives us 2. So that gives us an answer of, or a value of 1 in this case. In the second expression, we go 2 divided by 0 plus 2. Well, that gives us 2 over 2, which is also 1. So those answers are the same. Now we're going to do the same thing with 1. 2 times 1 plus 2 over 1 squared plus 3 times 1 plus 2. 2 times 1 is 2. 2 plus 2 is 4. 1 squared is 1. 3 times 1 is 3. So 3 plus 1 is 4. 4 plus 2 is 6. So when I simplify this, I actually get 2/3. Here we get 2 divided by 1 plus 2, and you're going to end up with 2/3. So it looks like there's a pattern here. It looks like we're actually going to get the same value for each one. Let's check one more. Let's put 2 in. 2 times 2 plus 2 divided by 2 squared plus 3 times 2 plus 2. Well, this is 4 plus 2, which is 6. 2 squared is 4. 4 plus 6 is 10, and 10 plus 2 is 12, and 6 over 12 is a half. Here we get 2 over 2 plus 2, or we get 2 over 4, which is indeed a half. And if we actually calculate the values for the next two, what we're going to see for the next two is that we're going to get values of 2/5 and 1/3. So, what can we say about the values of every value in the expression 2x plus 2 and over x squared plus 3x plus 2 and 2 over x plus 2? What we can say about all those values is that they're equal. That no matter what value we put in for x in the first expression, we're going to get the same solution in the second expression. So basically what we have is we have two rational expressions that look different, but they're actually equivalent because the values are the same when we plug in values of x. So what we're going to do next is we're going to look at simplifying that left-hand expression. We're going to look at simplifying 2x plus 2 over x squared plus 3x plus 2. How do we simplify? We have to factor. We have to cancel out any common factors that are there. So if we factor the numerator here, the first type of factoring you always try to do is you try to take out a common factor. So we can take out a common factor of 2 and we're left with x plus 1. If we look at our denominator, we need to use box method to factor this. We need two numbers that multiply to 2 and add to 3. Well, those two numbers are x plus 1 and x plus 2. So if you look here, we have common factors or common binomials in the numerator and denominator. We have x plus 1 in the numerator and x plus 1 in the denominator. So we can simplify those. We can cancel them out. That leaves us with 2 in the numerator and x plus 2 in the denominator. So what you're going to notice is that this expression, 2x plus 2 over x squared plus 3x plus 2, it can be written as 2 over x plus 2 when you put it in lowest terms or in simplest form. And that's something you're going to have to do all the way through this unit on rational expressions, is you're always going to have to write things in simplest form. If you look at 2 over x plus 2, we cannot further reduce this. The 2's in the numerator and denominator cannot cancel out. What we do is we reduce the fractions by canceling factors, not terms. So the 2, the x, and the 2 are terms. We don't cancel terms, we cancel entire factors. Just like we did up here, x plus 1 is a factor and x plus 1 is a factor. We cancel entire factors. We do not cancel just terms. Another way of looking at it is this x plus 2 in the denominator is a binomial. If I'm going to cancel this, I have to be able to cancel the entire binomial with something in the numerator, and because I cannot do this, I cannot reduce that particular situation. So we're going to spend lots of time at the beginning of this unit talking about how to simplify, how to cancel, all of that sort of stuff. Now, the other thing we have to look at in relation to rational expressions is we have to look at something called non-permissible values. Basically, a non-permissible value is values of x which we cannot use. And we're going to talk about why we can't use certain values. If we look at 0 and we plug 0 into each of these, we get 2 over 2, which is 1, and we get 2 over 2, which is 1. We get 1 and 1 there. If we plug negative 1 in, well, that's going to give us 2 times negative 1 plus 2 over negative 1 squared plus 3 times negative 1 plus 2. Well, that's negative 2 plus 2, which is 0. This is 1 minus 3, which is negative 2, and negative 2 plus 2 is 0. Well, 0 divided by 0, that's undefined. I can't divide by 0, so that doesn't work. Let's look what happens over here. If I go 2 divided by negative 1 plus 2, I get 2 divided by 1, which is 2. So negative 1 does not work as a value in our first expression, but it does work as a value in our second expression. If we look at negative 2, we take 2 times negative 2 plus 2 over negative 2 squared plus 3 times negative 2 plus 2. If we work this out, we get negative 4 plus 2 is negative 2. This is 4 minus 6, which is negative 2, and negative 2 plus 2 is 0. Again, we get division by 0. We cannot use that value in this particular situation. If I put negative 2 in here, I get 2 over 0. It's undefined. I cannot use that in that case either. So values that are, when you divide by 0, they're not values that I can use. They give us non-permissible values. If I plug -3 into each of these and calculate it out, I'm going to get a value of -2 in each case. So if I look at this table, 0 works. -3 works. But we have some interesting situations happening with -1 and -2. The next question says, for what values of x is this first expression not defined? Well, it's not defined for -1 and for -2 because when we plug in -1 and -2, we get undefined values. For what values is the second expression not defined? If we go down this column, the only value it's not defined for is -2. Why are these values not defined? Because we have division by 0. You cannot have division by 0. That's impossible. It's impossible to break things into groups of 0. Groups of 0 don't exist. So the values of the variable which relate in non-permissible values are also known as restrictions. So sometimes you're going to see in the literature, we're going to ask for what are the non-permissible values. Sometimes we're going to ask for what are the restrictions. And remember, the non-permissible values are the values which make the denominator equal to 0. That's really important, this part here. The denominator equal to 0 gives you a non-permissible value. Now, if you note, we had different restrictions or different non-permissible values for these two expressions. But earlier we determined that each of these expressions was actually equivalent. If we simplified the first expression, it gave us the second expression. So what you need to remember is that the restrictions must be determined before you divide out common factors. Or another way of looking at that is the restrictions must be determined before simplifying your rational expression. So in this particular situation, when we look at these two equivalent rational expressions, our restrictions are actually -1 and -2. We have to list both of them before we simplify and get the expression 2 over x plus 2. So the first thing you do before you factor, before you cancel factors, is you determine non-permissible values or restrictions. Absolutely important. Okay, so what we're going to do is we're going to look at listing the non-permissible values for these particular questions, and we're going to look at simplifying them. We're going to look at doing both because that's something we want you to be able to do in this particular situation. So if you look at rational expression, how do I calculate the non-permissible values? Well, what I do is I take what's in the denominator and I say that cannot equal 0. So 2x cannot be 0 because that'll give me a restriction. And I solve for x. If I divide each side by 2, that means x cannot equal 0 is my restriction. If I simplify now this expression, 12 divided by 2 gives me 6. X squared divided by x gives me x. So there's my rational expression in simplified form. It's 6x, and my restriction is x cannot equal 0. If we look at the second example, we do the same thing. We look at the factors in the denominator, and we say, okay, I can never have x plus 7 being equal to 0, and I can never have x plus 1 being equal to 0. You always look at the denominator to determine your restrictions. So if I solve this, one of my restrictions is -7, and another restriction is -1. So those are my two restrictions in this case, -7 and -1. Now when I simplify this, I cancel out these two factors of a plus 1, and I'm left with a minus 6 over a plus 7. There's the expression in simplified form. If you get a question where the denominator is not factored, the first thing you need to do is you need to factor that denominator. So what we have to do is we have to factor this denominator first. The numerator, there's nothing you can factor, but if you factor the denominator, two numbers that multiply to negative 20 and add to negative 1 are negative 5 and positive 4. So now that I've factored the denominator, I can equate each of these things to 0 and I can solve for y. Some of you are going to be able to just look at these factors and you're going to be able to figure out the restrictions without showing all of this work, and that's okay. If you can look at this and say y cannot be 5 and y cannot be negative 4, then go ahead and write that down. You don't have to show all that work. If you have to show all the work of equating it to 0 and then solving, go ahead and do that. Now, last thing we do is simplify. We cancel out these two factors of y plus 4. Y plus 4 divides into y plus 4 once, so we have 1 left in the numerator, and we have y minus 5 left in the denominator. Okay, the last question, we have to factor both the numerator and the denominator before we determine restrictions or we simplify. If we look at two numbers that multiply to 28 and add to 11, those are x plus 7 and x plus 4. The second case is a difference of squares. When you factor a difference of squares, the square root of x squared is x, the square root of 49 is 7, one is positive, and one is negative. So now I can determine my restrictions. X cannot equal negative 7, and x cannot equal positive 7, and I can cancel out my x plus 7's, leaving me with a simplified form of x plus 4 over x minus 7. So basically what we're going to ask you to do today as part of your assignment is we're going to ask you to determine non-permissible values or restrictions, and we're going to ask you to simplify some rational expressions. Remember, before you determine any restrictions, you have to make sure you factor the numerator and denominator. Then you determine the restrictions, and the third thing you do is you cancel things out.